Okay, so in this video I'm going to look at the binomial distribution again. I'm going to look at this particular formula which we've been using in a previous video. So we've got n number of experiments or n number of trials. R is the number of successes, P is the probability of success, and Q is the probability of failure. So in this particular question we're going to look at stopping people at random in a street and asking them what day of the week they were born. So we're going to repeat that process, keep asking people until 2 people who were born on a Sunday have been stopped and asked. So 2 people have been born on a Sunday. And we want to know what would be the probability that that's going to take exactly 12 people. So we're going to stop exactly 12 people and get 2 of those people who were born on a Sunday. Okay, so let's find the values for P and Q first. Okay, so P is going to be the probability of success. So the probability of finding someone who was born on a Sunday is going to be 1 out of 7. Probability that someone was born on a Sunday is 1 out of 7. So the probability that someone wasn't born on a Sunday is going to be 6 out of 7. 6 sevenths. Okay. So let's just stick these values into our formula here. We have n here is the number of trials. Now, just think about what's happening here. We want exactly 2 people out of 12 to be born on a Sunday. Now, what we would really like to happen then, therefore, is for us to have asked 11 people. 11 people we've asked, and we want 1 of those people to be born on a Sunday, and then the 12th person then would have to be the second person who's been born on a Sunday. So I'm just going to do 11 1 first. 11 choose 1 first of all. So we're just talking to 11 people. The probability of success here, the probability of success here is going to be 1/7. So we're going to look at 1/7. That's going to be to the power of R here, which is just 1. Probability of failure here is 6/7. And that's going to be n minus r, which is 11 minus 1, which is 10. So this is the probability here. This is where we've asked 11 people, and we've got 1 person who was born on a Sunday. Now we want the 12th person to be born on a Sunday. So the 12th person to be born on a Sunday, that's going to be 1/7 here. So all of this here is the probability that it will take exactly 12 people to get 2 people, exactly 2 people born on a Sunday. And if you work all of this out, 11 choose 1, 1/7 to the power of 1, 6/7 to the power of 10, multiplied by 1/7, you should get 0.0481. Okay, so that was our first example. Let's look at another one then. Okay, so I just move this up a little bit here. Okay, so in the second example then we're going to look at a woman who is carrying out a survey, and she phones different people. She rings different people to ask them a question. And she finds that when she rings them that only 20% of the householders reply to her questions. So only 20% people will actually answer her question. So that means 80% hang up or don't answer her question. Okay, she's going to keep on phoning these people until she gets 4 people who will actually answer her question. So she wants 4 people to answer her question. Now, what is the probability that it's going to take her 10 phone calls for this to happen? What's the probability that she's going to have to phone 10 times before she gets 4 people to reply to her question? Okay, so let's look at the probabilities again. Probability of P here is going to be, and the probability of Q here. So the probability of P is the probability of success. So the probability that someone actually answers her phone calls or answer her question is going to be 0.2. The probability that they don't answer her question, the probability that they hang up, is going to be 0.8. Okay, so now all we've got to do is stick these numbers into our formula here. So we have, in this case, what we actually want to happen here is for the first 9 phone calls we want 3 people to actually answer the questions, and then on the 10th phone call we want the 4th person then to answer the question. So we have 9 choose 3 here first of all, then we have 0.1, which is our probability of success, or sorry, 0.2, my fault, 0.2 here, looks like a 1 up here, it's actually a 2, so 0.2 here, and that's going to be to the power of or here, which is 3, and then we've got 0.8, which is the probability of failure. 0.8 is q, and that's going to be 9 minus 3, so that's going to be to the power of 6. Okay, okay, so now we want, this is the first 9 phone calls, okay, in the first 9 phone calls. So now she has to make one more phone call, the 10th phone call, and that has to be successful. So the probability of that being successful is 0.2. Okay, so this is our completed probability here, if you like. So when you work all of this out, 9 choose 3, 0.2 to the power of 3, 0.8 to the power of 6, multiplied by 0.2, you get 0.0352. Okay, so the probability then that it will take exactly 10 phone calls for her to get exactly 4 people to respond to her questions is 0.0352.